A neuron in artificial neural network can be considered as a numerical representation of the biological neuron. Both the biological neuron and the artificial neuron can get information inputs and transfer it to the next neuron it is connected to. A simple neuron network is graphically represented on the slide. It consists of some input neurons x1, x2, x3, xn, and one output neuron y. A neuron is also known as a node. The rest of the elements are collectively called synapses. The synapse is responsible for the connection between input and output nodes. This connection between neurons consists of weights, a transfer function, and an activation function. So this communication consists of W1, W2, Wn, which are weights associated to each input, as well as a transfer and activation functions, which are vital for tuning the data and transporting data between nodes. Weights can be assumed as importance of an input to a node. How important one input is to a neuron is actually defined by the value of the weight. If the weight is 0 for an input, then it means that the input contributes nothing to the value of the node. But if the value of the weight is high for an input, then it contributes a lot to the volume of the node. Now, onto the functions. So, functions in the synapse are some mathematical functions. Transfer function is the sum of all the products of each input by its weight. And activation function is a function that takes input from the transfer function and applies a function to the value in order to get another value and send it to the successive node. Weights are very crucial in neural networks because neural networks learn by modifying the values of their weights. And the neural network will then decide to how much a signal is significant in each case. It is possible that all signals are passed, no signal is passed, a low amount of a signal is passed, a high amount of the signal is passed. This is all done by changing weights while algorithms learn. We are able to do so by using gradient descent, GD, and back propagation, BP. In the upcoming lectures, we will learn about the meaning of gradient descent, GD, and back propagation, PB, in detail. Alright, now on to the next lecture.